Topics covered in relations and functions of sets. We'll start with something called the Cartesian product. Think of it as a way to combine two sets, basically, taking every element from one set and pairing it with every element from another. This creates a new set of ordered pairs, and understanding how to build these is our first step. Next, we'll move on to relations. A relation is simply a connection between elements of sets. We'll learn how to show these connections in different ways, listing the ordered pairs, using diagrams called mappings, or even just describing the connection with a rule. We'll also look at what kind of relation it is. Finally, and importantly, we'll focus on functions. Now, functions are a special type of relation. Not every relation is a function, and we'll learn exactly what makes a function unique. We'll also define key terms like domain, which is the set of all possible inputs, range, the set of all possible outputs, and codomain, which is a broader set containing the range. And we'll explore different types of functions too. So now we're diving into the core of this module, relations and functions of sets. This might sound a bit abstract, but trust me, these ideas are everywhere, and we'll see that on our next slide. But first, let's break down what we'll be covering. So, we're building from basic set combinations to understanding connections between elements, and finally, to the specific and powerful concept of functions. And as you'll see on the next slide, these aren't just abstract math ideas. They have real-world applications all around us. Real-world applications of relations and functions. In computer science, functions are absolutely fundamental. They're the building blocks of pretty much every computer program you use. And when it comes to organizing and finding information, think about databases. They rely heavily on relations to structure everything efficiently. Moving on to data analysis, understanding how different variables relate to each other is key. That's where relations and functions come in. We use functions to model trends we see in data, and then use those models to make predictions about the future. The same principle applies in engineering. Engineers often use functions to describe how physical systems behave. This allows them to analyze designs, predict performance, and build things safely and effectively. But it's not just limited to these technical fields. Even in everyday life, we're constantly dealing with relations and functions. Think about a recipe. It's essentially a function. You input ingredients, and it gives you a specific output, a finished dish. Or simply observing how one thing changes when another does, that's recognizing a relation. So on the previous slide, we started to define what relations and functions are, the mathematical concepts themselves. Now, let's look at why they're important. This slide highlights real-world applications of relations and functions. You'll be surprised how often these ideas pop up. So, as we move forward and delve deeper into the specifics of relations and functions, remember these applications. It'll help you see how these abstract mathematical concepts connect to the world around you.